Hi, this is Tariq Rashid. Today we have another class and we have a beautiful algorithm called backpropagation algorithm. This is part two, a theoretical part, and I promise that there will be a practical part for this class that we can take an example and we go through a network, a simple network, and how we can implement this network through and teach it or learning algorithm of backpropagation algorithm. Now, backpropagation, what's backpropagation? Well, it's a supervised learning algorithm to train neural networks. So it has two parts, forward pass and backward pass. Now, in the forward pass, we try to go all the way from input to output layer, and then we calculate error, and then we backwards, coming back all the way to update weight connection using gradients or chain rule. And the main objective is to minimize error of the network. Now, Paul Werbos was the first one who worked with the chain rule differentiation, which is a classical calculus. First clear formulation of the network, it was him, and he recorded this one in his PhD in 1974. And then later on, David Rumelhart, Geoffrey Hinton, the father of machine learning, and Ronald Williams. Three of them, they popularized and recognized it as backpropagation algorithm. They work with backpropagation algorithm in 1986, and they produced a paper which is learning representations by backpropagation errors in Nature. That was the paper. It was in 1986. Now, original authors are four. Paul Werbos worked with the classical chain rule, which is the way to get the gradients. And then these three people managed to popularize it and recognize it as a backpropagation through their paper. Now, core mathematics, backpropagation is based on chain rule. And there's also error function, error of the network. And so error of the network usually is this one. Error equals 1 over 2. Y is the target because it's a supervised, minus y hat or y dash. This is the prediction or the class label, the class that network produced. Y 1 over 2, that's for mathematical convenient, Now, gradient computation chain rule can be done by this way. So here, delta E over delta W, the partial differentiation of error with regards to weight connection equals partial differential of E with regards to partial differential of output, and then partial differential of output with regards to partial differential of net, and then partial differential of net with regards to W net, something like that. Okay, if this is the output, here is the out, and here is the net, and so the error goes back, and that's the connection weight. So if this one goes with this one, and this one goes with this one as this part equals this part. Now we have to find each part separately and we multiply them, and then we will get the change of error with regards to the weight. That's the idea. Now then that change of weight summed with the old weight, then we get the new weight for next iteration. And this is the learning rate for the network. Now, layer-wise error backpropagation, that will be delta for the output layer, and that delta with the change in error to the hidden layer. That's to the hidden layer. Now, backpropagation uses intermediate gradients efficiently, and then computational complexity is linear, and the number of depends on the number of weights. Now, why backpropagation? Well, most of the machine learning algorithms or architectures, they use backpropagation learning algorithm to train the network parameters. Example of these: deep learning, machine learning, transformers, recurrent neural network, convolutional neural network, and without it, training modern neural network would be computational infeasible. There's also meta-heuristic algorithm. They can use it to train these networks. Now, if we go to the structure of this back network, if we have two neurons and two hiddens, two inputs for the neurons, one output neuron, and wait for hidden neurons and wait for output neurons, wait between hidden and output. So, and then activation to normalize the net. Now here, hidden layer equals sum of weight multiplied by the inputs for the first layer. That's the output, which goes under activation function. Could be ReLU, could be sigmoid, could be sine, could be tangent. And likewise, we'll do with net 2 to get output. It again goes to, then we'll do the same thing with the net output until we find all the layers. And then the output prediction equals out, or which is activation function, net squash within the activation function, and then you get the output. Now, backpropagation, step by step, the first step, gradient layer. So that's how we can go with the first one, the output layer. We explained this one, and then derivative of this part is the derivative of this. So if derivative of 2 multiplied by 1 over 2, it will be 1. Y minus W multiplied by minus 1. So this goes with 2 multiply. So that's the derivative. So it will be Y minus Y hat minus 1. Okay, that's done. And this one, again, there will be a derivative for activation function, depends on the activation function. In the practical example, I will try to explain all this mathematically, so you wouldn't have to worry too much about it. Now, for the net, you will get that one for the output. And so 3 terms, this first term found and the second term, and that's the last term. And then you will get same thing for delta E over the other weight in the output layer. Now, that's how when we have that one, that's for the output layer. Now, for the hidden layer, we will have delta E over delta out over delta net over delta. So all these work together. So this would go with this one, this would go with this one, this would go with this one, and this would go with this one. So that is, I mean, this all, that one equals this part. Now, the chain rule works with the, I mean, sigma of all delta in the out multiplied by the next terms. Here we have the delta that we know already in the output, and here we have the delta net over delta H, which is only delta W5, and here we have the delta out of the delta net, which is only X. So that is how we found all weights in the between input and hidden layers. And then we work with the updating of this weight, this new change plus the old weight, you'll have the new weight. So thank you very much. Stay tuned for the second part, which is a practical example of this work. And I appreciate your your listening and watching this video. Thank you very much.